Hi, good evening, everyone. How are you? All right, I am Mr. Chu here. Okay, with me today I have Teacher Lina. Teacher Lina will also be answering some of our questions. Okay, so if you have questions, feel free to put them in the chat. Okay. All right, so today we'll be covering the topic of electricity. And I already have questions coming in from in the chat. One question here, how do we know for electromagnet which pole is north, which pole is south? Okay, you'll learn this concept in secondary physics. Okay, for PSLE, you don't have to know. All right, so do not worry about which pole is north, which pole is south. Okay, not at this level. Okay. But definitely there's a north and south pole. Okay, so the question will give you some information whether it's attracting or repelling. Then from there, you can infer which is the north, which is the south. But you don't have to know it based on your background knowledge. Okay, it's from experimental results. Okay, right. So for those who just joined us, okay, the link is in the chat. So if you have not downloaded the material, all right, feel free to just access that, download it. Okay. Hi, Hemingen. All right, so I'm going to go through the questions. You don't have the material, Johnson? Uh, Hannah, can you send it again? Then some of them just joined us. Yes. Yeah. So Johnson, you have the link already. Yeah. Okay. So again, the link is in the chat. So if you have not received the material, no access that in the chat. Okay. And if you have any questions regarding this topic, electricity, or regarding your science, feel free to chat with us. Okay, just put in the chat. All right. So I'm going to begin. Let me just share my screen. Hmm. Okay, great. So I'll start off with some recap. Okay, fundamentals, fundamental concept that all of you must know before you can even do the questions. Okay, so a quick recap on some of these important points. Okay, so along the way, again, like I said, if you have questions, feel free to just check with us. Right? Now, in an electric circuit, we have components. We call these components the wire, the battery, the bulb, the switch, all these common components in the circuit. Right? And of course, in order for the light bulb to light up, it must be a closed circuit. Okay, so the closed circuit allows current to flow. Okay, without the current to flow or electric current to flow, then nothing is going to work. The light bulb will not light up. Okay, but in order for your light bulb to light up also, all of these must be connected correctly. The light bulb must be connected to the metal tip and metal casing. Okay, the batteries, if I have more than one battery, okay, then the positive terminal must be connected to the negative terminal of the other battery. It must be in this order, right? In order for them to work. Okay, so there are different ways to arrange the bulbs. Okay, it could just be the terminal of the battery connected to metal casing or metal tip of the light bulb. So all these can still work. Okay, otherwise use a wire. Okay. Circuit symbols, all of you should be very familiar. This one, I will not go through this. You should by now know this. If you do not know, please go through them again. Okay. Now, I talk about the conductors and insulators of electricity. Okay, so we must know that all metals are conductors of electricity. Okay, that means that they allow electricity to pass through, okay, or flow through. These are electric conductors. Okay, and all metals can. Can you also tell me which other element, which other substance can also conduct electricity? Hmm. What other substance? Okay, water. Right, technically, pure water cannot actually, or very, 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 very little. Okay, yes, graphite. Graphite is actually carbon. Yeah, salt water is a better one that allows electricity to pass through. But if you're talking about pure water, then uh, it's unlikely to allow electricity to pass through. But the salt water, it contains the salt there, so that allows the current to flow through. Okay, I have a question. Let's see. What if there's a bulb with only metal casing attached to the wire, and there's another bulb properly connected, and they are working? Okay, Megan, let me just try to figure out what you're trying to say. Okay, there's a bulb with a metal casing attached to the wire. So only the metal casing, another bulb connected correctly, and then we have working battery. So with the second light bulb, yes, as long as there's current flowing and that one light bulb is connected correctly, one to metal casing, one to metal tip, then that second light bulb will light up. But the first light bulb that only connected to the metal casing, then the current will flow through, but the bulb will not light up. Okay, so you must understand that for light bulb, right? So we have all these light bulb. How does it? So I show you, like, for example, this is a light bulb. What it looks like inside is, okay, you have a wire here. So there is this conductor inside, and then it goes to the filament, and then it goes to the tip. So there's like wires and then the filament made of tungsten. Okay, so it must be connected like this. Okay, so if only connected to the casing, then the electric current will just pass through the casing without going through the filament. Okay? Yan na? Why got molybdenum? Natasha, to answer your question, the salt can conduct when it's dissolved in water. So that's why the salt and water together, then it becomes a conductor. Okay, the salt itself is if it's a solid, it can't. Only when it's in water. Okay? We call it an aqueous solution, but never mind, this one you learn it in a higher level. Okay? Uh, Shaden, why do you have to mention molybdenum? There's another metal. So yes, it's just a metal. Oh, you have a lot of questions already, huh? Sometimes the wire connected to casing the other bulb won't light up. Um, I think you have to look at the whole circuit itself. There might be something that is connected wrongly. Okay, so I won't be able to tell you straight away just like that. But a light bulb will light up as long as there's current flowing through the wires in a closed circuit and it is connected correctly to the metal casing and the metal tip. Unless the light bulb has fused, then that's another story. Okay? Great. Pencil lead is your graphite. Okay, Junyang, pencil lead is made out of graphite, which is carbon, another element. Okay? Tap water is not pure water. Okay, tap water is not pure water. It contains other things. Hmm. Wow, this one very specific. Give me a school paper for me to check. Maybe teacher Lina, you can help me see whether you can find this worksheet online. I think some of these test papers might be online. Maybe you help me search if you can find it. Okay. Okay, let's continue with this. I have a lot of questions here, but let's try to finish what we have here. Okay. So circuit symbols not cover. Okay, then conductor elect. Okay, so just now I talked about graphite. This is the one used to make pencil lead. Okay, so this is an electrical conductor. It allows electric current to pass through. But most other substances which are not metals, they can't conduct electricity, so they're insulated. Okay? Right. You have learned about factors affecting brightness of a bulb, right? Such as number of batteries. Now, for batteries, right, you only learn one arrangement. That is series. Okay, parallel arrangement of batteries is no longer in syllabus. So we just learn series arrangement of batteries. Okay, and it's very straightforward. The more batteries you have, the brighter, the more current flows through the circuit. So the light bulbs will be brighter. Okay? But if we have too many batteries, then of course too much current causes the filament of the bulb to melt. And therefore we say that the bulb has blown or is fused. Okay? So no current can flow through and the light bulb will not light up. All right? Now, but in terms of light bulbs, okay, then in your syllabus you have learned number of light bulbs as well as arrangement, be it series or parallel. So assuming we have the same number of batteries, the more light bulbs connected in series, the dimmer each of the light bulb will become. Okay, you see here, for example, I only have two batteries in each circuit. At first, I have one light bulb is the brightest, but when I add an additional light bulb in series to the first one, it becomes dimmer, and another light bulb, all of them becomes only 2 units of brightness. Okay, so it becomes dimmer and dimmer. All right. Hmm. Okay, let me answer some of this question. How many batteries does it take for the light bulb to explode? It's not going to explode, the light bulb will fuse and it just stop working. Okay, no explosion expected. Parallel circuit is still in syllabus, Srira. I was just saying that for batteries, you don't learn batteries in parallel arrangement. Okay, but parallel arrangement of the bulbs is in syllabus. Okay, so that is still tested. Rainwater is not pure water. Okay, some of these questions. How come two exposed wires touch each other will catch fire? Okay, when the wires are exposed, they may cause sparks to occur lah. Okay, so sparks may result in fire because there's still some current trying to flow through. Okay, especially when they're very close to each other, and that might result in spark, and that might start to burn something because the sparks will fly. Okay, so if you have things like paper, curtain, something nearby, then that catches the fire. Okay? Parallel is syllabus. Okay, all these have answered. Will the setup stats that it is definitely pure water? They are, okay, if it's supposed to be pure water and not conducting electricity, they will tell you. Okay? But if they say they use tap water, they use salt water, then those can conduct electricity. All right? For the two in exam A, closed circuit for the electricity, let me try to understand you, Zhe Yang. Do you mean that uh do you mean that electricity or electric current in your answer? Is that what you're trying to say? You can use either electricity or electric current, or simply current is enough for PSLE. Okay? Okay, let me continue. Okay, now, so what happens when you add another light bulb in parallel to existing light bulb? Now, so in this case, you will take it as this is one loop. Oops. This is one pathway. This is another pathway. Okay, this is another pathway. So they are separate pathways, right? And the same amount of electric current will flow through these parallel pathways. That's why the light bulb becomes equally bright. I mean, they will be equally bright. That means that if I add a third one, I add a fourth one, they are equally bright as long as they are all parallel to one another. Okay. Now, one thing is what I know is that for student, you all can mainly understand all these concepts, but when you're asked to draw, I notice a lot of students still struggle with the drawing. Okay, like for example, how do you draw adding a light bulb in parallel? That's why I add it here. When you add a light bulb in parallel, you want to draw the wires across or around the existing light bulb. So for example, this light bulb here, when you draw across or around it, that means that you have another wire coming from the left wire of that, another wire coming from the right wire of that. Okay, and this is now across. Okay, of course I need to change this. Okay, so this is what I mean by across. Okay, so around the first light bulb. All right. Of course, all these must be connected properly. Yeah. Now, when you draw, please use pencil to draw because you are likely to make mistakes and you need to erase, you need to draw, you need to erase. So don't use pen. Okay, please use pencils to draw. Okay. If there are two light bulbs arranged in series with the bulbs of the same brightness, yes. Okay, if there are two light bulbs in this parallel is not what does that mean? This parallel is not in syllabus. Uh, let me see other questions. If the two light bulbs are identical, yeah, then they will be the same brightness, okay? Which most of the time in PSLE questions, your light bulbs are identical. Okay, they are unlikely to use different light bulbs. Okay. So if let's come back to the top right. So all like this, right? All these three light bulbs are identical. They are in the same circuit, same loop, same pathway. Okay, then they will be equal. They will be equally bright. All right. But you definitely have seen questions whereby, like for example, I add another light bulb here, assuming connected correctly. And then what will happen? This one still remains the same, but this one will reduce because in this pathway, okay, in this pathway, there are two light bulbs in series. Okay, so these two light bulbs will share that current flowing through. So they will be less bright as compared to the one below. All right. Uh, this is in syllabus. This is in syllabus. Yeah, this is in syllabus. Huh? When they are equal number of many batteries bulb, will the bulb still fuse? Okay, then what are you trying to say? Equal number of many batteries or bulbs. What is it, battery or bulbs? You write again. Okay, next one. So when I compare series and parallel circuits, okay, in this case, I have same number of batteries, assuming identical ones. All right, and I have two light bulbs in each, but one in series, one in parallel. Okay, so the one in series, because the two light bulbs share the current flowing through that pathway. Okay, so it will be dimmer. But for the one in parallel, there's only one light bulb in one pathway. So it will be brighter. Okay, now one easy way to go and determine the brightness is using this formula. If you have not learned it before, please use this. Okay, this is one easy formula. Let's try it out. For example, the one above, right? Number of batteries, I have two. Okay. Number of bulbs in the path, in this path, okay, there are two light bulbs. So 2 over 2 is equal to 1. So each of these light bulb has 1 unit of brightness. Okay, so 1 unit, 1 unit. If I go on to the next one on the parallel circuit, number of batteries is still 2, but in this path, there's only 1 light bulb. In this path, there's another light bulb. Okay, but they are separate pathways. So number of batteries is still 2, but there's only 1. So this is unit of 2, this unit of 2. So the one on the light bulbs on the right are actually twice as bright as those on the left. Okay, if we use this formula for reference. Okay, so there is one easy way to go and determine your brightness. All right. Let's move on. Okay, so this is just another example. Okay, which we have tried before just now. Okay, so let's go through this again. So in this one parallel, I have 4 light bulbs here. I have 4 light bulbs here, okay, with 2 batteries. So the 2 batteries, for each of these paths, there's only 1 bulb, right? So 2 over 1, that's it. But the one on the right, now this is a bit more complicated, right? But this is also in syllabus, okay? It can be tested. So I have 2 batteries, and I have two bulbs in each path. So 2 over 2, 1 unit. So each of these is 1, 1, 1, 1. Compared to the one on the left, all these are 2, 2, 2, 2. Okay? Hmm. Can I all make sure you all know how to use this formula? When chlorine is added to water, in the first place, the swimming pool water it can already conduct electricity because it's not pure water. Okay, so the swimming pool water with or without the chlorine, it can conduct. Okay, you ask funny questions, huh? Everything in the world you have to know. Yes, even your bathtub water, if you still use a bathtub, which is very rare nowadays, yes, it is tap water, right? So it conducts electricity. So must be very careful when you use electrical appliances in your toilet. Okay, try not to. Okay, I think all the questions are answered. Okay, now, apart from knowing the how to calculate brightness and all, you must know the advantages and disadvantages of arranging light bulbs in series and parallel. Okay, so when we arrange the light bulbs in series, the battery actually lasts longer. Because you know why? For each of these, right? Okay, I compare these. Each light bulb here, only 1 unit of brightness. So it actually used less electric current at that point of time, at every moment. Okay, as compared to the one on the right, in parallel, if each of these light bulb is 2 brightness, 2 units of brightness, 2 units of brightness, then they're actually using a lot more energy from the battery. Okay? So that's why the one in parallel will run out faster, it will die out faster. But the one in series lasts longer. Alright? Now, but the advantage of using parallel is that when one light bulb fuse, the others will still remain lighted up. Okay? Okay, this advantage is just the concept, right? It's dimmer as compared to in parallel. Okay? So sometimes you do not want that. So that could be a disadvantage. Alright? Now, then the problem is if one of the bulb fused, then the series circuit, the remaining will not light up because it's in one single pathway. Okay? So this one I already explained. This one is related to this. Any questions on this? Okay, I think some of the questions are answered. Thank you. Okay, any more questions I need to answer? Okay, so let's move on. Right, let's do the questions. Have you all tried the questions? All right, now let's go through. Okay, wow, I already got answers in the chat. So you have tried. So maybe let's try to use our the formula. All right, since I have taught you that, let's make use of that. Okay, because we do not know. I mean, the formula is very useful. We do not know what they're going to come out in exam. Okay, these are the very commonly tested. Okay, very common tested setups in the circuit. Okay, so if you know the formula, you'll be better. In case in the exam they come up with something strange, you could still use the formula to help you. Okay, so now let's use the formula. Okay, number of number of batteries is 2. Number of light bulb in each path is only 1. Right? In this path there's 1, in this path there's 1. Okay? So that is 2 over 1. So it's equals to 2. Alright? Then the one on the right. Can you tell me the brightness of the light bulbs in circuit Y? Well, all very eager to share your answers. But can you help me find out the level of brightness of the light bulb in circuit Y using the formula? Yes, thank you. Thank you, Jason, Harris. Yep, yep, yep. Okay, so I think all you got it, right? So you know how to use the formula. So 2 light bulbs, but I have two batteries and I have 2 light bulbs in the same path. So 2 over 2, this is 1. This is 1 unit. Okay? So you can see the one on the right in circuit Y, it is dimmer. Those in X would be brighter. Okay, and the answer is 3, which most of you got it right. Okay. Very good. Yes, answer is 3. Okay, any questions on this? Any of you are P5 here? I just want to know like any P5 here. Okay, a few of you. Great. Yeah, I think all these are also very useful for the end of year exam. Yeah. Oh, okay. Shira also. Okay, great. Yeah. So take note of all these formulas. Okay, how to find out the brightness. Okay, very useful. All right, next one. So you're going to practice this a few times. Okay, because I would say this will be the more difficult kind of question. If you do not know how to do a simple calculation, then it becomes difficult. Okay, so I'm going to teach you that how to use that formula. Okay, there are of course other types of electricity questions, circuit card, number of light bulbs that light up. I think those are easier. Okay, it's all about analyzing your circuits. You must look very carefully. Okay, so those I did not cover here. I'm not covering those here, I think. Yeah. So mostly on determining the brightness. Right? Now, which of the following statements here about the circuits are correct? Okay, so in order to know all this, let's find out their brightness again using the formula. Okay, so for circuit S, I have two batteries. Okay, then I have one light bulb. So this is just two. For circuit T, one battery, but in each path, I only have one light bulb. So 1 over 1 is just 1. Now, in the circuit U, one battery, two light bulbs in the path, so this is half. Okay, this one don't need equal, it's just half. Then the one on the right, okay, this one is 1. 1 over 1 is just 1. So from here, you can already tell the brightest is in S. This is the brightest. Yeah, I put it all here. So all these are the analysis you must do first before you really go and look at the options. Okay? So this is one, and this is the dimmers. All right. So once I have analyzed this based on all my values here, okay, then I can look at the options, which makes it easier. So bulb in S is the most brightly lit, and we have already calculated that. We have concluded that. Bulbs in U are the most dimly lit, yes. Bulbs in T and V are equally bright. We have calculated that, right? All of them have 1 unit of brightness. So they're all equally bright. So A, B, and C are correct. Do we have our answers? Yes. So answer is 4. Okay, but let's look at option D. Bulb in V is as bright as bulb in S. So V is 1 unit, but in S is 2 units. Okay, so D must be wrong. Okay? So answer is 4. Alright, answer is 4. Let me see. Wow, some of you using your answer everywhere. Okay, your sister is also in P5. Okay, okay. Okay, so I go back here. Question 1 is 3. If you did not catch that, question 1 is 3. Question 2 is 4. Okay? And okay, next one. Question 3. Question 3. Okay, let me know your answers. What's the answer for question 4? Sorry, question 3. Just put your answers in the chat, okay? So that I can see what are the important questions in the Q&A, because I see the answers everywhere, like Q&A, also in the chat. A bit messy, a bit hard for me to manage, okay? So can y'all please put your answers only in the chat so that I can see the real questions in the Q&A. Okay? So I can help as many of you. Otherwise, I'm just trying to clear all these answers, which is not very effective. Yes. Okay, so I have seen many answers. The answers are one. So let's look at the formula again. We want to see in which circuit would bulb Q be the brightest. So Q here, Q here, Q here, and Q here. Okay, first option. Two light bulbs in the path that bulb Q is in, there's only one light bulb. So 2/1 is just 2. Okay? What about the second one? One light bulb, sorry, one battery. But how many light bulbs are there in this path? Now you have to be very careful. A bit tricky here. Okay, you might think that, okay, why this happen? You might think that this light bulb is in a different pathway. You have to be very careful. These two are in the same path, just placed in a different position to confuse you. Okay, so these two are in the same path, so it's 1/2. That's half. Okay, for number three, option three, three batteries and three bulbs. This is 1. Okay, and for the fourth one, again, I have two light bulbs arranged like this, trying to confuse you. Okay, so don't get confused, don't get tricked. Two batteries, two light bulbs. So it's 1. Okay, so you compare, which one is Q the brightest? So we have option 1. Okay, I hope all of you are annotating this down, so that you know what to look out for, okay, when you all revise this. All right. Okay, any questions? Ask real questions, Okay. All right. Yes. Real questions. Funny. Okay. Question 4. When will you learn periodic table? Kiran, you learn periodic table in Sec 1. Okay? Kiran, it's good to be curious. You actually can learn already. Just read up. The internet has everything nowadays. If you're interested, feel free to just read up. Okay? Right, question 4. Okay, this one is a modified PSLE question. Yeah, you might have seen some of these before. Looks a bit different from your regular rectangular kind of circuit because this one is like there's a diagonal pathway. Okay, but don't be too confused. It's going to work the same way. Just look at where the wires split. Okay, where it separates, where it splits into two paths. All right, so this is the wire coming from the battery. This is also the wire coming from the battery on this side. And then it splits into two separate pathways, here and here. Okay, then it joins back here, then it joins back here. So maybe let me redraw this in case it's confusing for some of you. If I put it in a rectangular one, okay, this is your two light bulbs. This is Q, this is R. Okay, can you see that it splits into two pathways? And this is your S. Okay, pardon my beautiful drawing. Okay, so this is exactly what it looks like. If I put it in a more rectangular, more familiar scenario, it's the same. Just that they want to put it slightly more difficult, put it in different orientation, different direction. Okay, but essentially it's the same. All right, now, so they ask you which change will allow all bulbs to light up with equal brightness. Now, maybe let's find out their current brightness first. I have one light bulb. Sorry, why I keep saying the wrong thing. I have one battery, okay, but I have one light bulb, bulb S in this pathway. So for bulb S, this is 1 over 1, which is just 1. While the one with Q and R, it is 1 battery over 2 bulbs. So that's half. So they are not the same, right? How do I make it the same? Okay, let's go through the options. If I add one more battery, what does that do? It just causes all the light bulbs to become brighter. It has not make them equally bright. So it is wrong. One is wrong. Okay? And an identical bulb in series to S. What does that mean? Okay. So if I add another light bulb here, okay, this is what option 2 means. Add an identical light bulb in series to S. Okay, I put it beside S. Now that changes this formula. Now it becomes 1 battery, 2 light bulbs. Okay, isn't that identical to the path of Q and R? So 2 may be correct. But it is always good to go through the options so that you always choose the best answer. If maybe you are not so confident, I think that 2 is correct, but you should, if you're not 100% confident 2 is correct, okay, go and eliminate your choices. Okay, so let's look at option 3. Add an identical light bulb in parallel to S. Okay, so I will remove this. If I add an identical light bulb parallel to S means like this, across S. Will it change the brightness of Q, R, and S? Now I'm adding it parallel to S, which is also parallel to Q and R altogether. It actually does not change their brightness. Nothing has changed. Because remember, as you add a light bulb in parallel, the light bulbs will be equally bright. Okay, I mean, if these existing light bulbs will be equally bright. Okay, so this one, let's say I call this U, bulb U. So light bulb U will be as bright as light bulb S because I have 1 battery and 1 light bulb in this path. So it has 1 unit of brightness. Okay, but all these light bulbs together, they are not equally bright. So number 3 is wrong. Okay, and it's actually the same as option 4, right? Option 4 and option 3 are the same. If it's parallel to S, then it's parallel to Q and R. So these 2 are the same thing. All right. If it's parallel to S, it's also parallel to Q and R altogether. All right. Okay, let's look at your questions. This one, what answer is 2? You know the answer is 2, yes. So yeah. Okay, you know the answer is 2. So that the brightness is the same as there is the same number of. The brightness is the same. Annabelle, what do you mean? The brightness is the same as. It's not that they have the same number of bulb and batteries. If you mean that in the same pathway, there is the same number of light bulb as the one with Q and R, then yes, that's correct. Okay, so which means that you want the 2 pathways to have the same number of light bulbs. So that is when they will become equally bright. Okay, can I also answer is 2. Okay, yes. What is periodic table? Okay, you don't even know. Okay, let's move on. All right, question 5. Okay, so we have finished the multiple choice questions. Okay. So in a PSLE exam, right, you realize that there could be 3, maybe 2 to 3 electricity questions. And one of them might be this question of brightness. Then the rest will be like, oh, how many light bulbs light up? Or how many more light bulbs light up? That was a question, I think 2024. Sometimes you have to read the question very carefully. They can be very tricky, Some of the question I just saw recently, it was about the number of light bulbs that light up. Okay. Then the question actually asks, how many more light bulbs light up when a certain switch was closed? So if you did not read the question carefully, that they want how many more light bulbs, which means that how many additional light bulbs light up on top of what already was lighted up, and then you'll make careless mistake. Okay? So it can happen. All these are very important keywords in your question that you realize that sometimes some students, right, they can do very well for their regular practice. But when it comes to PSLE, sometimes they didn't do as well. Maybe they didn't get an L2. And all that could be due to the MCQ. Because remember, each MCQ is 2 marks. Right? You made a careless mistake, you didn't read the question carefully, then you have a problem. Okay? So I had one student also ask me in the Telegram. They did very well for the open-ended questions, but for MCQ, wow, they struggle. I mean, not that they really struggled, but they lost like 10 marks just in the MCQ. I remember, is it 10 marks? Okay. But there's 5 questions wrong, and could be careless, to be really didn't know, but that's a lot of marks, and 10 marks means your AR1 is gone. Okay, so MCQ must be extremely careful. Okay, let's come back here. Right, what is wrong with this circuit? Okay, what are the things that are not correct? That's why the light bulb did not light up. Battery, batteries position, okay, bulb magnetic connection. How to show my answer? No, you just let me know. This one you cannot show, like, you just tell me what to change or what is wrong. Okay, battery is not connected, right? Light bulb only connected by the casing. Okay, so you should be able to identify the problems here, right? Okay, so battery not correctly arranged. Okay, this is the positive terminal of the battery. This is the negative. This is the negative. This is the positive. All right, so one of these must be flipped. Okay, one of it must be flipped. It's like you have someone, back to back. Your back is facing another person's back. Okay, by right, you queue up, right? You queue up, everyone face the front. Okay, so now it's not correctly arranged. Okay, then for light bulbs, can you see that both light bulb A and B, the casing is connected, but nothing is connected to the metal tip. So again, will not light up. So for such a question, okay, you just need to correct these mistakes. Okay, so for the battery, it will look like this. Okay, everything else remains the same. Just change the orientation of the battery, flip one of the battery up. Or if you want both to face point downwards, also can. Okay, then the light bulb, since I already have one wire to the casing, the other wire must be to the metal tip. Okay, so this is an example. So this wire to the metal tip here, okay, then goes to the casing, then the other wire goes to the metal tip. Okay, so just correct the errors and redraw everything. Right. You don't have to add the plus and minus. No need. Not needed. Okay, then I will have students who ask me, so can I draw circuit symbols? Can I draw circuit symbols here? What do you all think? You be the teacher. You think you can draw circuit symbols here? You think you can draw circuit symbols? No, right? Okay. You cannot be drawing circuit symbols, right? Because they already give you the actual diagram, actual picture of the bulb and the batteries. How can you anyhow go and change to circuit symbols? Okay, so you stick to what they have given you, just make them correct. Okay, the question did not ask you to use circuit symbols. Okay, so don't do that. But of course, one thing is that the switch, Okay, because the switch is one thing that is very difficult to, or rather, it's not really needed to go and draw the actual switch. All right, so that remains as a circuit symbol. But the rest, keep to what they have given you. Okay, if you realize the switch is a circuit symbol. Yeah, you draw the batteries the other way, that's fine, Ginny, that's fine. Which means that you have drawn both of them downwards. That's okay. Because it's still, as long as they're connected correctly, that's okay. Can we draw wiggly lines, like lines that are not straight? Uh, I would say it's best to draw straight lines. Okay, then I have students in my class who are trying to be very funny. I have students in my class ask me, "Sir, can I just draw like this?" Why would you want to draw like that? Okay, just make your answers concise, straightforward. Don't make it funny. Okay, there's no need to do this. Okay, so please do not when try to be funny. Okay, just draw straight lines. In the exam, would this come out? We do not need to draw the symbols. What do you mean, Annabelle? This kind of question can come out, and it came out before. Yeah, it came out before many times. Will you get penalized when you draw wiggly lines? The standard is wires are straight lines. At most curve a little bit, but wiggly line is not the standard. Okay, so who knows? If they don't like you, they deduct your marks. Just kidding. Okay, but please just try to draw straight line. Don't need to be doing extra on that. Okay? Okay, one of you are asking for question 4 again. Suki, is the question answered? Question 4. Sorry, just backtrack a little bit. One of you is asking for question 4. What's the answer not option 4? Just now I explained, right? If you put the bulb in the path of S, then there will be path of S. No, when they say that you add it in parallel, then it will be added separately parallel. Okay, so it's not that I add it in parallel, but unless they say that they put it beside S, but that's not right. So if they put it beside S in series, that is number 2. That's the answer. But when they say it's parallel to Q and R, that would mean that they add it separately, meaning that I have another light bulb here, which is the same as what I've already drawn just now. So when they add parallel to S, it's the same as parallel to Q and R on a separate loop, separate pathway. Okay, not beside S. Because the question did not say that it's beside S. Okay? When drawing parallel and about drawing parallel when they purposely give you light bulbs in series, how to draw. Okay, good question, Mingen. Actually, that happens a lot of time, right? If they ask you to draw parallel, but somehow they place the light bulbs in series. Let me see if I have something like that. Okay, something like this, right? Uh, okay, maybe it's not. Okay, maybe I try to draw out what you're trying to say. So one student here asked that, okay, what happens when they give you light bulbs in series, but they actually ask you to draw parallel? Yes, you can still draw parallel. You just need to arrange your wires. You just need to draw your wires correctly. So for example, okay, if let's say I still have the same thing, okay, I still have the same thing. Okay, let's say I just have one battery, So I give you 2 light bulbs. I put it in parallel. Fantastic. Okay, now, so this looks like they are next to each other in series. How do I draw it in parallel? Remember what is the thing I mentioned to you? What is the trick to draw parallel circuits? This is not really a trick, but this is the method to draw a parallel pathway. So when you add when you add a bulb in parallel to another light bulb, draw the wires with the new light bulb around the existing light bulb. Okay? So how do you do it? So the method is, right, to draw the first circuit first, the first closed loop. Okay, so you draw wires from this this terminal of the battery. Okay, so you draw a connect here, you form the first closed circuit. All right. Then I just need to connect this parallel to the existing light bulb, isn't it? Okay, so what is the trick that I told you? You draw it across, right? So the wire on the left side, let's assume this is the left, you just connect it to this casing. Then the wire on the right, which is the tip here, just draw it to this casing. Then they are parallel. So it's all about your wire placing. The position of the light bulb is to make it more difficult for you. You are supposed to draw parallel, but somehow they place the light bulb in series. So how you draw it? This is the way. I repeat again. You draw a closed circuit with one of the light bulb. Then the second light bulb, loop it around the first light bulb. And there's a parallel circuit. Okay? This is the one I was telling you many students cannot visualize this. Okay, it happened in my strategy worksheets as well. I saw some of my students, even the makeup students, you see, when I saw them draw, you cannot draw parallel. Okay? So please, yeah, don't overlap the wires. Don't overlap the wire. If the bulbs are on top of one another, if the light bulbs are on top of one another, isn't it very easy to be parallel? Let's just try to figure it out. I have one light bulb here. Okay. I have another light bulb here. Okay, how to draw them parallel? Same thing. It's all the same method. You draw a closed circuit for this first. Okay. Then you draw over around this light bulb. Isn't that parallel? Okay. Yeah, don't overlap the wires. Okay. And it has to be connected to the switch. How to do? A lot of questions. Let me see. If the turns are not 90 degrees, I think it's okay. Okay. Cannot overlap wire for electric current to flow through and light up the latter circuit will require a switch, right? May or may not require a switch. Actually, you don't need a light. You don't need a switch for it to be closed. A switch is just there to make it easy to control, to switch on and off, but it's not necessary. Okay. What if the question says that you need to draw that extra bulb parallel to the original and has to be connected to the switch? If it has to be connected to a switch, then put that switch in that path one. Okay, what do you mean by that, Sherry's? So let's say I need a switch here, right? So if I need a switch, then you just draw a switch. Just draw a switch here. Okay? It's okay if the turns are not exactly. Yeah, if it's not 100, if it's not right angles, it's fine. It's fine. It does not have to be all right angled. It doesn't have to be very, very, very straight. Okay, not to worry about all those. But just don't go and draw wiggly lines. Yeah, just draw it as accurately as possible. Okay, so don't try to overshoot the drawing or what. Okay, so make it as accurate as you can to avoid losing any marks. Or if one switch, the bulb, you mean the switch control both bulbs? Okay. If the switch control both bulbs, then this switch must be in series to the battery. It must be connected directly to the battery. Cherise. So I remove this. So it's not about this light bulb. Okay, so these two light bulbs are still parallel. But if I want a switch that can control both light bulbs, then the switch must be directly connected to the battery. Okay? Oop, got something wrong. Not here. Okay, so it can be like this. You have a switch here. Okay? So once this is open, both cannot light up because it's connected directly to the battery. Once it's open, it's an open circuit. What if you have two switches in parallel? Then which will work? Uh, which one do you want it to work? If you have two switches in parallel, then that one switch will control whatever is in that path. So if you want things in that path to work, you close the switch. Not too sure what you're trying to mean, Johnson. Okay, I'll move on. So I'll answer some of the questions later. Okay, now question 6. Okay, so this is on application. Okay, now such a question, you try to follow this chain of thought. Okay, first thing is a closed circuit, right? So you follow through. The first thing you think about is the current flowing through. Okay, after the circuit is closed, the switch is closed, current flows through, and then there will be magnetism. Spell wrong. Magnetism. Okay, then that leads to attraction, right? Attraction, or it could be repulsion. So take note, it could be repulsion as well. Okay, then what is your observation? Is usually this chain of thought. You close the switch. Okay, you close the switch, there is an electric current flowing through. Then that must have caused something to become a magnet, electromagnet, attracted an object or repelled an object. And what is the observation? Do you hear a ding sound? Do you see something happening? Okay, or what? Okay, so depends on the question. So when you talk about this question, describe what will happen when the switch is closed. Okay, so when we close the switch, what will happen? Same thing, right? First thing, electric current. Okay, electric current will flow through. Or you can just say current. But what does that result in? So when current flows through this circuit, okay, then this iron cylinder becomes an electromagnet. And what is it going to do? Okay, so if it's becoming electromagnet, this is an iron striker, which is magnetic material, right? Okay, this is an iron striker, so it will be attracted. Okay, so it will be attracted to the electromagnet. That's it. Okay? Because we just need to just need to describe what happens when the switch is closed. Okay? And yes, only magnets can repel each other. Does the electromagnet has a north and south pole? Yes, they have. How do you know which side is north and south? You don't need to know. Okay, I mentioned at the start, right? And for all to know again, electromagnets, they are magnets. So there is a north and south, but that is beyond what you need to know. Okay? Except that you can deduce the north and south based on experimental results, which came out in PSLE before. So you just need to know that there is a north and south, but based on experimental result, you may know what is north, which is the north, which is the south. Okay, but you don't have to, based on your knowledge, know that which is the north, which is the south. Okay, so based on experimental results. Okay, moving on. So when the switch is open, a ding sound can be heard. Explain why. Why would there be a ding sound? Okay, so just now, when we close the switch, okay, I have current flowing through from an electromagnet attract this object. Okay, so that is the observation as well. Then suddenly there's a ding sound. Why would there be a ding sound? We have a bell here, right? The bell can ring after something hit the bell. So now we need to reverse the process. Okay, what will hit the bell? It must be the iron striker. That's why it's called striker. Okay, it's going to hit the bell and produce the ding sound. Now we need to go through the whole process. What happens when we open the switch? So we reverse this whole process. Okay, so we reverse the whole process. First thing, just now the iron cylinder was an electromagnet. Now it stops attracting the iron striker because it no longer has magnetism. Okay, so if it does not attract the iron striker, what's next? Eileen is best to add that. Yeah. Okay, so you no longer attract the iron striker. So what is happening next? What's the next thing that happens? Nobody. What's the next thing that happened? Is electricity a tough component, tough topic, you mean? Rufra, it depends. Okay, it depends on you. If you find that you're struggling with it, then it's tough. Some students find it okay. Okay? But you must learn the correct method to do it correctly. Okay, such questions, many students cannot write the full description, and then it becomes tough. Okay? So what's the next thing that happens? Okay, so now many of you will miss out on the spring. Okay, many of you will miss out on the spring. That's why it's okay. Not string, spring. Okay, Iron Striker will be released. What do you mean by that? Iron Striker will be released. Okay, so you have to talk about the spring. The spring is there for a reason. Jason, as well, you say you swing back. Why will it swing back? What is causing it to swing back? Okay, these are important points. All of you must listen. Okay, whenever in such a circuit, a lot of times we are dealing with not just electromagnets, but also with spring. Okay, some concept of forces. There's a spring there that is pulling something. So in this case, once there's nothing attracting the iron striker, the spring is going to pull the iron striker back. Okay, or pull it. This is very important. Many of you will miss out this. Many of you will miss out the spring. You just say, oh, it bounced back, it gets pulled back. By what? Did you mention that? Okay, so missing out the spring is an error. Because what is causing you to go back? Nothing. You must mention the spring. Understand? Okay, so once it does that, then that will hit the bell, produce the ding sound. All right? Will you get the whole question wrong if your lines have gaps? What kind of gaps are you talking about, kids? When you ask to draw a circuit with a switch, must it be open or closed? You can draw it open or closed, I think doesn't matter, unless they specify. Okay, unless they specify. The closed circuit one is a bit hard to see. So make sure you draw a two circle to show that the start and end of the switch. Sometimes good question here. Sometimes the electric circuit drawing questions, right? Sometimes it's 2 marks, sometimes it's 3 marks. I think it depends on how many things they need for you to take notes. Okay, maybe there are multiple errors, and then there's some wire connection. So they can give you marks based on your wire connection, your arrangement of your light bulbs, okay, your connection to the light bulbs. All this can be given marks. So it depends on how many parts there are to the question. Okay? So you of course one part wrong doesn't mean you get zero. Okay, so it depends on the question itself. Because sometimes 2 marks, sometimes 3 marks. It depends. Okay, Hayden, tomorrow is a prelim, so you have questions, please ask now. And you better sleep early, Okay, next part. State a change that can be done to the setup to produce a softer ding sound. I want to produce a softer ding sound. What should I do? Now we have a few things in play, right? We have the electromagnet, we have the spring. What are the possible ways? What are the possible ways? Actually, I just answered the question. You can draw it. You can draw the switch open or close. Okay. Do you have to talk about elastic spring force? You can, but if you simply just say the spring pull it back, I think it's fine because it's not. This is mainly not a force question. Okay. Yes, you must talk about the spring pulling it back because there is a spring. Otherwise, what is pulling it back? Reduce the stiffness of the spring. Yes, possible. Or not that you reduce lah. Okay, you can't say you reduce, right? Because the spring is fixed. So you have to use another spring that is less stiff. But I mean, your idea is there, but you can't just reduce the stiffness of the spring. So you change to a less stiff spring. Okay, one of you said that reduce number of coils. I think that's okay. Remove some batteries. I think that's fine. Okay, or reduce the number of batteries lah. Okay, yeah. So it's either you use the spring that is less stiff, or you reduce the strength of the electromagnet. So that will produce a softer ding sound. Because if you use if you use a weaker electromagnet, it will attract the iron striker with a smaller force. And therefore, when it's released, it's a smaller force also. Likewise, if you use a less stiff spring, so the elastic spring force is weaker, then it will hit the bell with a smaller force. Okay? Cherise, how does it lose the magnetism? No, they say that the switch is open. They say that the switch is open here. Cherise, the switch is open. Yeah, Ariel? Ariel? What is the difference between elastic spring force and elastic potential energy? You didn't attend my webinar when I talk about energy and forces. Oh no. Okay, I've explained all those. If you can find you can actually access those in YouTube. Okay, but you may not. I don't. Yeah, you can find the materials. You can find the materials in the Telegram channel. Okay, I actually went through forces and energy in the previous webinar. Okay, so feel free to go and find that. You can find the recorded video in YouTube as well. Okay, that part I went through, like elastic spring force and elastic potential energy. Okay, which is the best? Sun, electric current, electricity, or current? I would say currents because it's short and straightforward, and it's still correct. So why would I write electric current when I can just write currents? Okay, if you have your science textbook, right, you realize the science textbook just say currents, so it is accepted. All right. And electricity is a more general term. So actually the more accurate one is current. Okay, I move on to the next question. Question 7. For question 7, again, we are drawing the circuit. Now here is 3 marks, yeah? So take note here. All right, what do I need to do? I need to know what to draw. Now, in this question, I'm not trying to correct anything. I'm trying to draw the circuit that they want. Okay, based on this information. So X lights up when Y lights up. Okay, I can't tell much from that. They are in the same circuit, that's all. All 3 light bulbs light up when the switch is closed. I still can't tell much from that. I cannot tell how they are connected. The third one, only bulb Z lights up when the switch is open. This tells us something. Only bulb Z lights up when the switch is on. When the switch is already open, but Z is still lighted up, that tells you what? It tells you that the switch does not control bulb Z. Okay? The switch controls only X and Y. That is something I can conclude. Right? Because Z is still lighted up, but X and Y have went off. Okay? So from here, I can tell something, right? If the switch only control X and Y, okay, and it does not control Z. So In this case, how do you think they're arranged? The switch is most likely together in series with X and Y. Then Z must be a separate pathway, so it's likely to be parallel. It's likely to be parallel. Okay? So let's try that and see whether it works. Alright, so, okay, now you try to understand these fixed metal plates. Some of you might not have seen metal plates like this before. Actually, you can find it in all your devices. You can find it in your devices. If let's say your house has a remote control, right? A TV remote control, you can actually find these metal plates inside. You have not seen one before. Or any devices, even like your digital thermometer, it's all there. Just open up the battery compartment, you will see such things. Okay, so all these are signs, these are not rocket science, it's just normal science. Okay, so all these metal plates are there to act as conductor to complete your circuit. That's why sometimes we put our batteries in all these devices, all these appliances, right? Your battery must be up, down, up, down, up, down. Okay? Because the metal plates are arranged like this. All right? So in this case, can you see that this part here is the negative, this part is the positive of the battery. So this negative part of the light of the battery must be connected to the positive end of the battery on the other side. So you draw that battery. Okay? Then what do I need to do? So if I concluded that Z is parallel, how do I do it? We can draw Z on its own first. So let's draw Z on its own in one single loop. Okay? Then X and Y are together. The light, the switch controls both X and Y. So I just need to complete the loop and the switch must be somewhere in there. Okay, so you can draw something like this. Okay, bulb Z parallel to X and Y together. Okay, and the switch is in the middle. So the switch controls X and Y, but when it's open, Z is still in a closed circuit. Okay, and you go, once you have drawn all this circuit, right, make sure you double check again. Are all these still correct? So when X lights up, Y lights up. Of course, because they are in series, they are in one single pathway. All three bulbs lights up when the switch is closed. Z will already light up. Switch is closed, X and Y will light up. So yes. Okay. Only Z will light up when the switch is open. Okay, so yes, because the switch only controls X and Y. And then we are done. Okay, so once you have drawn, always double check with the information they have given. Can you put a switch in front of Y? What is the in front? Do you mean here? As long as they are on any part of this path is fine. Okay? Yeah, as long as they are in any part of this path is fine. You want to put it here, put it here, put it here. Doesn't matter, right? Because they are still some part of the same path. Okay, so that's okay. I drew the switch just above the wire connected to Z. The switch just above the wire connecting bulb Z. Just, Uni, I'm trying to understand what you're trying to say. The switch just above the wire connecting to bulb Z. Isn't this the above the wire connecting to bulb Z? Not too sure what you're trying to say, Uni. Yeah, you can draw a closed switch is fine. But make sure you show that it's a switch with the two circle at the ends. Okay? So you share your answer in the Google Drive. Let me see. Let me see if I can open that. No, who is this? You cannot draw it like that. Now you all must remember when you draw when you draw your wires to the light bulb, there should only be two wires. I see some students drawing three wires to your light bulb. You only have what is required of you is only one wire to the casing, one wire to the tip, nothing more. Try not to draw more than that. Okay? It gets very confusing even for yourself, not say the examiner. Okay, so just one each. Isaac, one. Okay, where did that go? Never mind. All right, let me move on. Okay, part B. So compare the final brightness of the bulb after another bulb is added in series to Z, and the switch is closed. Okay, so now I add one more that's here. Okay, let me use a different color. One more light bulb here. Okay, assuming connected correctly, yeah. So assume this is connected correctly. So what will the final brightness be? Now I have X, Y in one path and this new one with Z in the other path. So okay, let me draw this nicely. All right, so once I've added this, there are two light bulbs in each pathway. Then they should be equally bright. Like what some of you said. Okay, they should be equally bright. Because now I have two light bulbs in the pathway, in each pathway. So 2 over 2. So all of them will be 1 unit of brightness. Okay? We want to talk about all the bulbs, because they just say that final brightness of the bulbs. So these bulbs will refer to all of them. Bulb W. Did they say it's W? No one says W. Okay, can I move on to the last question? Done, Okay, question 8. No, not yet. Yes, ask please. Why must eat another battery? Huh? What do you mean? Why must put another battery? We need it to be a closed circuit. Okay, I have this metal plate here, and one end of the battery is connected to the metal plate. So it must be a closed circuit by having another one here. Okay, so don't go and draw wires like that's why I saw one of you, your wires are here, everywhere. No, the wires are, okay, this part is given to you, right? So the wire comes from the top of the top metal plate. So on this side, do the same. Wire coming out from here. Okay, so this forms a closed circuit. But why not use the wires? Why not use the wire? You mean what? Can you see a full screen of question 6? Question 6. You do a quick screenshot. Full screen. Um, I don't know if you can see the full screen here. Are you able to see the are you able to see the full screen in this? Won't the bulb brightness of Z decrease? Yeah. Let me exit this. Brightness of Z decreased. Yes, it decreased, correct. But that's not what the question is asking, Eileen. Eileen, you're right that the brightness of bulb Z decreased. That's correct, as compared to it initially. But we're asking about the final brightness of the light bulbs. So we are not talking about how Z has changed, but we're talking about the final brightness, comparing all the light bulbs together. So your answer could be like, oh, maybe X is brighter than Z, or the new one is brighter than Z, or something like that. But all of them now have the same brightness. You are not wrong that the brightness of Z has decreased, but that's not what the question wants. Brightness of X and Y will be the same. Will be the same. So, okay. Okay, some of you went to talk about the change, but the question is not asking if how the brightness have changed. They're asking for the final brightness. So there's a difference in the meaning. Final brightness means that, okay, now I have added this new light bulb. I want you to compare the brightness of the light bulbs. I'm not comparing to before I add it. I'm asking you to comment on now the final brightness comparing to each other. Okay? Okay, let me finish up the last question. Okay, let me finish up the last question, and then later you all have any more questions, I'll answer. Okay? Because it's going to be 9 o'clock soon. Your last question, I have PQR light bulbs in the circuit. Okay, switch is closed. The magnet moves between A and B repeatedly. Okay, this is not an easy question, so listen carefully. Explain why magnet moves between A and B repeatedly when the switch is closed. Now, the first part is still largely similar. Right? Why something happened when a switch is closed? Okay, then go through the process. I have current, I have the magnet forming, and then the attraction or the repulsion. In this case, if it's moving from A upwards to B, it's a repulsion. Okay? So it's a repulsion. That means that the light poles are facing each other. Because some of you asked me right just now, electromagnet has poles? Yes, they have, but you don't need to identify unless the question needs you to. Okay, but again, not based on your background knowledge. So in this case, they repel, okay, and therefore it moves up. But once it moves up, what happens here? The magnet is supposed to close the circuit here. But once it's repelled, this becomes an open circuit. Correct? Then it's no longer repelled. So it will fall back downwards and then close the circuit again. So that becomes a cycle. Okay? So you must mention that, oh, in this case, because it's repeatedly, right, you must always mention that, okay, the process repeats itself. So you know that it's a cycle. All right? So first thing, the current flowing through the circuit, current forming electromagnet, then the attraction or repulsion, okay, then the observation from A to B. This is just talking about it going from A to B. We have not mentioned why it's a repeated process. So just now I have mentioned, right? So once it leaves the position A, it forms an open circuit. Okay? So now there's a gap, it's an open circuit. Okay, so there's no more repulsion. So there's no more repulsion, or you can say that it's no longer an electromagnet. Therefore, the current magnet will fall back to A. Then that close the circuit again. Then the process repeat itself. Okay, you must end off with this. All right, model. What model? Yeah. Yeah, I need to move on soon. I don't want to extend this too much. Okay, but in case you need to revisit some of this, or you have some answers, some annotation that you have not made, okay, feel free to watch the recording. Okay, that will be uploaded on YouTube. All right, let me move on. Next one. Now, when the magnet is at B, state how the brightness of bulb P changes. Explain your answer. So now it goes back to brightness. Somehow this question with this application goes all the way back to brightness. Okay, so let's look at how it is just now. Okay, at the start. When the magnet is at A, how many light bulbs are there? How many batteries are there? Okay, so this is the initial closed circuit. This is the initial closed circuit. Okay, I just quickly draw it down. So I have two batteries and I have P, Q, and R in series in the same path. So now it's two-third. Okay, two batteries powering three light bulbs. But what happens when it moves to B? Okay, this is at A, this is at A. Now at B, what happens? The circuit is only like this. Okay, let me use this machine. Whereas at B, the circuit is just like that, a small one. Two batteries, two light bulbs, P and Q only. Okay? So you can see, right, it is bright, you become brighter. Okay? So it will become brighter because more current flows through P. Now remember, it's all brightness at your level is just all about current. Okay? So if there are more current flowing through, then it is brighter. Okay? So you talk about just now, okay, I have initially only two bulbs in series, okay, compared to three bulbs in series. Okay, so more current flows through. That's why it's brighter. And okay, last one, last one to finish it up. Okay, last one. After operating for a few hours, the magnet moves slower than before. Say another change to the movement of the magnet. Now, what could have caused this to happen in the first place? Why did the magnet move slower? It is still happening, but slower. But what is something else that can also happen? Okay, these are all possible PSLE questions, or rather, most studies have came up before. Okay, this is a PSLE question that is modified. So all these were tested before. So if you cannot answer, then please practice more, okay? Because these are very important concepts, came out before and can be tested again. So other than moving slower, what else could it be? But why did this happen? All right. Okay, so first thing, I think as an electrical device or appliance using two batteries, eventually batteries will run out, right? They become flat. We are using energy. Okay, then some of you ask me, can I answer in terms of energy? Yes, you can. They didn't say you cannot. Okay, but you can also answer in terms of you can also answer in terms of just normal electricity. Okay, that the battery is used up. Okay, then less current flows through. Okay, so the first answer here, okay, I did not say what else will happen. So other than moving slower, because there's less repulsion, right? Okay, if the battery gets weaker, this electromagnet is now weaker, then the repulsion will be weaker. Everything else is weaker. Okay, repulsion is weaker, that means that this one will not go any higher. Okay, it might go to a lower height. Eventually will not be at B, right? It will start to go lower and lower and lower. Okay? So you move on to a lower height. Then you can explain in terms of the current. Okay, battery being used up, less current flows through. The simple one, based on electricity. So less current flows through, but you don't stop there. Less current, weaker electromagnet, repulsion, weaker. All these are comparative terms. Okay, so make sure you talk about less. Lower height. See another comparison. Lower height because of less current flowing through, weaker electromagnet, weaker repulsion. Okay? Or you can explain in terms of energy. Right? So in terms of energy, okay, if we have battery, then what kind of energy it has? Potential, right? So potential energy decreased. Okay, that the answer is the same. Potential energy decrease or have less, right? So converted to less electrical energy, which still leads to the same endpoint, weaker electromagnet, weaker repulsion. Okay? I've underlined the keywords, so you must know what you need to write. Lower height. All right, so you can answer in terms of electricity or in terms of energy. Okay? Tops will be dimmer. Eileen, which one are you talking about? Bulbs will be dimmer. B is it? Bulb is brighter one. Okay? So I'll leave this here. This is the last question already. I leave this here. I think one of you want to see the annotated diagram. Okay. That's a quick one because everyone is copying the answers. Okay. So, like I said, if there are any annotations that you still need or any answers that you still need, okay, all this will be uploaded on YouTube. So feel free to revisit again if you need to. Okay. Or if you want to redo the questions, then check the answers again on YouTube. Please do that. Okay, if you need to. All right. So I hope this has been a good practice for you for this topic of electricity. All right. If you still have any further questions, I'll stay here for about maybe 5 more minutes. Okay, let me know your concerns, your questions. All right. You just need to write either one. Please don't go and write all of them. This Travis keeps spamming. I need to block this Travis already. Please do not spam. Okay, right. So that's all for this session. Like I said, if you still have any further questions, I'll stay behind for 5 minutes. Otherwise, thank you so much for joining us. I hope you have learned something and improve your techniques to answer these electricity questions. Okay, so place your last questions in the chat or Q&A. We'll look at the latest ones. Okay, because otherwise there's too many messages. Right. Otherwise, thank you. We'll see you again. Like, do take note that in September holiday we have our boot camp, last lab boot camp. Okay, that will be your final chance to ask us questions. Okay, it will be online boot camp. Okay, from morning. Okay, starting from morning. So do take note of the timing, the dates. For science is on Wednesday. Okay. All right. See you guys there. Okay, I'll stay here for a while more to answer some of your questions. All right. So for 6C. Comparative terms refers to using words like more, less, greater, smaller, the comparative terms. 6C. Yes, how does the strength of the electromagnet affect the sound? I think the strength is stronger the itself. It will not strength of the electromagnet, right? So you see, if it's a stronger magnet, you will pull it closer to itself. Okay, you pull it closer to itself, it is stronger. If it's weaker one, it doesn't pull with the same amount of force. Okay, it doesn't pull with the same amount of force. So if it's a stronger one, it will pull with a greater force, and the spring will exert a greater elastic spring force. But if it's a weaker electromagnet, it does not attract that much with a smaller force, the elastic spring force will also be smaller. So you will hit the bell with a smaller force. Okay, it's mainly about forces. Isaac. Yeah. Okay. Uh, three, 3 marks, 2 marks electric circuit questions. How are the marks split? And just now I already explained 3 marks and 2 marks. It really depends on the question and what kind of circuit question are we talking about. Okay. If it's connecting, or correcting, maybe correcting the mistake. I think that's the trend now. Correcting the mistakes in connection. It could be 1 mark for correct arrangement of your light bulbs. Second mark could be whether your wires are drawn correctly. Okay, so first thing, arrangement, whether you have correctly arranged them, and your connection, it could be connection to your light bulb, connection to your battery. Okay, if it's 3 marks, then it depends. There could be more than 2 things to look at. Okay, could be connection, could be arrangement, could be wires. Okay, it really depends on the question. So I can't tell you for sure. 8A, wait, 8A, yes, 8A. If you want to look at the diagram, right? Okay, or the answer. Okay, let me zoom out later. Hope you all can see. Why the rate of repulsion decreases? It decreases because the battery is weaker now. Okay, so things will be weaker, slow down and all. Yeah, I think a lot of A's, question A is all here. May I ask to close the circuit of 2 series bulb drawn in? Huh? May I ask to close the circuit of 2 series bulb drawn in parallel? Why must there be a line drawn at the tip of bulb A and B? Wow, trying to hard to understand your question, Isaac. Kids, electricity is not likely to be the hardest, but it really depends on person. You may find it difficult, other person may find it not so difficult. So it depends. But I will not say it's the most difficult. There's so many Isaac, okay. Need to upload screenshot, but cannot. Can you access? What screenshot? You mean your diagram, is it, Charis? Okay, Isaac, can you try to repeat that again? I don't understand your question. Yes, what, Megan, and what? How many marks will you get for what? If we say, can we say a lot of CPE in battery was used up by the EE in the iron rod? What is EE? Electrical energy? Used up by the electrical energy? What do you mean? Since when we say energy is used up? Alright, because we don't say energy is used up, right? Energy converted, a lot of energy has been converted to electrical energy, and therefore the iron rod has weaker strength and weaker repulsion, therefore. Yeah, so it's not about using up, right? So you use the wrong word already, converted to, right? But otherwise, I think the rest are okay. It's the keywords you have used wrongly. Upload screenshot. Upload screenshot. There is. Okay. Maybe I don't know whether you have a mobile device. I just give you my number. You send to me. Can you WhatsApp me on this? Or ask your parents to WhatsApp me. I just send my number to you. Okay. I'm asking for a circuit diagram, circuit drawing with bulbs drawn in series, but the circuit need to draw in parallel. Is it just now that I draw the one is this? Isaac, is it this? And what about this? Uh, close the circuit of the book. Question 6. Question 6, when asked the bulb drawn side by side. Question 5, you mean Isaac? Why the tips are connected? Why the tips are connected? Uh, okay, I'm just gonna put my number here. So anyone needs to reach me, please just go ahead. Okay, I'll help all of you for your PSLE. If you need lah. Okay, send me a screenshot of your drawing if you need to. I'll answer you when I can, okay? Isaac, yeah, so why the tips are connected? It must be connected to be a complete circuit. What do you mean by why are they connected? Yeah, lah. 8B, 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 yes, here. Sorry. Okay, any more questions? Will you get the annotated version on Telegram? Yes, I will upload whatever I've annotated here on Telegram, just like the one on energy and forces. Okay. Otherwise, you can also revisit on YouTube. Okay. 7A, I put the switch where the other battery was supposed to go and connected all these to. Let me go to 7A, try to see what I talk about. Put the switch where the other battery was supposed to go and connected Z to the Y, connected that to the Y in the middle. No, you cannot connect to the middle of the metal plate. Okay? You cannot do that. Yeah, so can link, so that is not correct. Okay? Then why? Minden, what are you talking about, Minden? What then why? Okay, any more questions that I have not answered? Please write again. Because I think there's a lot of messages coming in. Part A again. Okay. Now, if you have any more questions, you can also put in the Telegram, or otherwise I already put my number in the chat just now. Okay. You can ask in the Telegram also. I'm there. Okay. If there are no further questions, I think that would be all. Any more last one? Okay. Right, I think that will be all for today. So thanks all of you for joining us today. I hope you have learned and make use of all these techniques for your PSLE. Okay, I'll see you in our bootcamp. Thank you so much and good night.